All right, let's see. There's not a whole lot of new PRs this week. A bunch of folks are off at Red Hat Summit, so things are a little slow. But we can quick go through them, and then I don't have too much, but we'll go through it here. So let's see. There is this new PR for Rados GW admin to allow for like unordered bucket listing. Casey, you might be able to talk about that better than I can.
Yeah, this is an extension of Eric's earlier work, enabling unordered bucket listing from the S3 API. Bucket listing is supposed to be ordered, and our shards are not ordered. So to order them, we basically have to query a listing from every shard and correlate them. But with unordered listing, we can just list one shard at a time. So it ends up being a lot more performant.
And does that then is that something then that we have an extension to the S3 API, or how does that how does an application know or say that they
Exactly.
want?
Yes, we have an extension for S3 and Swift to allow unordered unlistings.
Okay.
So we've been looking for other places to use that. Um, so like the check for whether a bucket is empty can use the unordered listing. Rados GW admin doesn't really need to order stuff, so using it there makes sense.
Nice. Cool. All right. Let's see what else we have. An upgrade on C Star. There's some performance improvements there, so Kifu merged that. There's this zero copy writes via the C API for librd. That was a small performance improvement that got merged. And then some of Radek's work got closed out by the stale bot for buffer list. So I don't know if he'll revive that or not, but stale bot decided it was too old. Let's see what else for updated. Some of Adam's work, of course, is continuing to be updated, so that's good. The Igor's RocksDB prefetch stuff was found to be slightly buggy when Sage tested it, or at least he thinks it is. He thinks it's that one, so that needs more testing and someone to go back and look at it again. I'll talk a little bit about the double caching my PR in a little bit here. Turns out it's going to be unfortunately more difficult than we were hoping. And then this IOU ring, I've been looking at that this week. PR. There's some work that it needs. It kind of makes use of some of our existing AIO infrastructure in kernel device and Ceph IAO. And we can't, well, one thing is that we can't use pread in the IOU ring kind of land anymore. So I've got another PR out actually that just switches our AIO code to use pread v instead of pread. That is fine. I don't think it causes any performance regressions or anything, and no advantages really. It's basically just doing the same thing it did before. But that's one step that's needed to be able to use this IOU ring PR kind of as is. But then there's some other stuff going on too. Kind of a lot of this code came out of the FIO IOU ring engine, and so there's some stuff in there that kind of needs to be cleaned up for our code. And there's potentially maybe some barrier or also locking issues in here. So I'm kind of trying to simultaneously learn the IOU ring code while also kind of going through it line by line to figure out how this is different, in what ways this is different than FIO's code, and then also kind of why we might be seeing some of the issues in it that we're seeing. So yeah, anyway, that's it for that PR. So yeah, that's kind of it for IOU ring. Still testing it. It sort of works, but not well yet. So okay, Blue Stored Ono double caching. So the PR I think works well. It passed when Niha tested it. It passed kind of all the Rados tests. But Josh raised a very, very good point earlier this week about what happens when a user starts changing column families around, either through my PR, which does it kind of behind the scenes implicitly, or just starts changing the dev option that enabling or disabling certain column families. And Niha ran some upgrade tests, and it sounds like those are failing. So the answer might be that bad things happen when you start changing column families around. As part of the sharding work, Adam is working on some tooling to make it so that you can migrate. And he offered to potentially extend that to also allow for migration when you have column families that are storing prefixes. In this case, it would be the onode prefix. So maybe there's a way out. But maybe I think probably the bigger issue beyond just my PR is that right now, I think it's probably likely that a user that starts modifying these dev options back and forth on an existing cluster, either live or just through the ceph.conf and restarting OSDs, could run into some really big issues. So we may need to do something to prevent that from happening one way or another. And then also my stuff probably needs to be layered on top of Adam's so that the tooling for migration is kind of already in place, and we issue warnings not to upgrade without running that tooling beforehand, or maybe it happens live. I don't know, but yeah, one way or another, my PR probably can't be merged right away. So unfortunate, but that's the way it is. So that's basically all I've got, guys. Any questions or comments on any of that stuff? All right. Well, then, anyone want to talk about anything else this week? All right. Well, go ahead.
Oh, sorry. Yeah, if no one wants to talk, I have something. If there's interest for LVM cache.
Absolutely.
Cool. Can I share my screen? A small presentation.
Yes, please.
Can you guys see my presentation?
Yeah.
Perfect. Yeah, so I just ran benchmarks for the past couple of weeks for LVM cache. I compared basically a setup that I have. I have a 4 nodes cluster with each node has 3 spinners and 3 SSDs. And I have 3 different setups. So the first setup is a no cache setup. I only have 3 OSDs on the spinners, and the SSDs are unused. The second setup is with caching, with LVM cache. Okay. So I use it for OSDs, and on each SSD, I use it as an LVM cache. So each OSD on spinner has one SSD that is used as an LVM cache. And finally, the final setup is a WAL setup. So I use the SSDs as WAL-DB devices instead of LVM cache. So I think that's mostly what's interesting, comparing LVM cache versus WAL on a fast device. Yeah, and I ran it with a Q depth of 16 and 32. I'm mostly focusing on latency, not IOPS, because some of my benchmarks have limited IOPS. So I have three types of workloads. I have a full throttle, so push as much data as possible. I have a bursty one, which I use with think time in FIO, and I have a sustained but low IO workload. So I have a bunch of graphs, so I won't start at all of them, but if maybe at the interesting ones, I'll stop. And I've used 4K and 4M IO for all of the scenarios. So you can see the green line is the one with caching, so it shows the latency in milliseconds and nanoseconds here. So the green one is with the cache setup, the yellow one is the while, and the blue one is no cache at all, so only spinners. In most cases, so the no cache setup is obviously always the worst one, but while and cache are similar. I'm just going to go through them quickly, and I have the final results at the end. So for this one, for instance, sequential reads with 4 M's, 4 megabyte blocks, it seems that cache is doing much better than the other two if we use LVM cache instead of a separate wall, which I think makes sense, right? Because we have data in a fast device. For random writes, this is a bursty. This one's interesting. This is a bursty workload. The caching setup, so if you use the SSD as an LVM cache, it has a much better latency, much lower latency than if you use it as a WAL device, because the workload is bursty.
Was the data set size big enough to cause the cache to have to start evicting?
Well, that's why this is interesting, because here we don't have there's no. So this is a bursty think time of 2 seconds. So you have 2 seconds between each burst, and each burst is has a acute depth of 16. So basically, we have 2 seconds. That gives enough time for the SSD to flush its data, and that's why we have a much lower latency. Where if it was a full throttle one, they're all similar.
I
This
see.
is the full throttle one. Yeah, but for a bursty one, it looks like for a bursty one, LVM cache is better.
Yeah. Did LVM cache usually do the eviction within that 2-second window between bursts?
Yes. Let me show you something actually interesting. Do you see my terminal?
Yep.
Here I'm on that set cluster. By the way, LVM cache, I have my own Ceph volume plugin. So if I run Ceph volume cache stats, these are the statistics, and I see that. Let me just stop it. The last columns, you see the percentage of dirty blocks. So now they're all 0 because I had no traffic. And IOStat, it shows the top 3. So SDD, E, and F are the OSDs, and H, I, and G are the LVM cache. So the fast. If I look at what's happening and I workload, this is the bursty one. So I have 2 seconds between bursts. You see the dirty blocks remains at 0%, the percentage. And if you look at the IOStat, you see that and the downtime, so between bursts, this is only 100% write workload, but you see reads on the SSDs because due to flushing.
Sure.
So you see reads and writes on the SSDs. So the writes are the workload, the reads are for flushing, and you see writes on the OSDs because the flush, and see the percentage of the dirty blocks is always 0. So in this setup, this is great for LVM cache. If I stop FIO and I keep it, full throttle, then the percentage of dirty blocks will just increase, and then performance really becomes terrible because you have a sustained workload and you need to flush the SSDs. Performance just becomes very bad. It's gonna take a while to happen now. Yeah, but that's just what I've noticed.
When you were running tests, did you notice even though you saw like a higher or a latency benefit, did you see significantly more writes on the SSD one way or the other?
Did I see more or fewer writes for either one of the setups? Is that your question?
Yeah. So like, what was the write workload on the SSD in both configurations? If you kind of just ignore the performance, what was the amount of work the SSD ended up having to do?
I didn't really compare. Oh, okay, no, for the WAL or okay, good point. I haven't kept track of that.
Okay.
Yeah, obviously you see writes across all devices for the WAL setup. Yeah, no, I didn't keep track of that. That's a good point. I look at what's happening.
Okay. Yeah, I'd be curious for two different reasons. One is in this kind of a setup, I imagine that the SSD probably can absorb a lot of write traffic. So if for like LVM cache, I definitely could see it being a performance gain. But maybe, I guess the first thing I'd be worried about would be wear on the SSD. And then the second thing I'd be worried about is this may not actually be as much of a problem when Atom's starting stuff gets merged and TRXDB and all of this, but whether or not if you could enter into a situation where once you have really big compactions, if it's like a big RGW workload or something, if then you start seeing compaction compete with LVM more.
Yeah, that's a great point. And let me just switch back to the presentation. I think I've seen a workload where the latency increases for a while, and I suspected that it might be compaction, actually. I would be able to find it. Here, maybe. No, that's a read. Anyway, I cannot find it anymore. A bunch of tests, but I think I suspected I saw an increase in latency at some point with the WAL setup, and I suspected it might be compaction that came to and
Sure.
increase latency, but I couldn't really verify it afterwards. Yeah, for I will look at the amount of data that is written for sure. I mean, if you're worried about tear on the SSD, then yeah, for sure the AVM cache is the more hard on the SSD for sure.
Yeah.
The cool thing though that I noticed is that for small writes, the WAL setup is always better.
Sure.
Which can be expected, right?
Yeah.
If I just look at the, I know, if I ask myself which is better for a bursty workload, it looks like the cache setup is better, the LVM cache setup, as long as the SSDs is able to keep up with flushing and the incoming traffic.
It'd be really interesting. Is Josh here? Josh is here. It'd be really interesting to know after you've done a bunch of work, especially work that has like a lot of OMAP, how much OMAP data, how many of the SSTs you end up with sitting on the NVMe or SSD device versus how much data you end up with on it, and how that compares to dedicating a bunch of space on the SSD drive just for the DB, and what the trade-offs end up being there when you start becoming when that space becomes scarce.
You're talking about the amount of data that is used in the SSD after a while, right?
Yeah, and especially kind of given our current like issues that we have where you may not be able to fit an entire level on the DB device, so it ends up going over to the block device. LVM, if you did it that way, that would kind of fix that, right? Now all of a sudden it's just it throws whatever it thinks is relevant on the SSD presumably. I guess I actually don't know that's how it really works, but I would assume it would keep some of it over there before evicting. So it'd be interesting to know kind of what ratios you end up seeing and how well it works versus kind of our current scheme, and then how will it work with Adams sharding and kind of how that will look.
Mm-hmm. Yeah, that's a good point. No, I've only run each workload for 20 minutes, so obviously that's not enough to really stress it or kind of answer these questions. I'll try to. I don't know if I'll have the cluster for long. I'll try to run to kind of extend these workloads and see this. For the cache setup, it's pretty straightforward, I think. Yeah, for the wall one, I'll try to fix. Yeah. Also, in this setup that I had one SSD per spinner, so one separate device for one OSD, one separate cache per OSD. So that's really the best scenario you can have. Which,
Sure.
I mean, real life probably won't be that. Probably one fast drive for a few spinners. So probably SSD for like one SSD for 3 or 4 HDDs probably won't be worth it, because you're really splitting the maximum IOPS the fast drive can get you. You're really splitting it even by the number of OSDs you have, and that's for all your requests. So it really gets, unless your fast drive is super fast NVMe, probably not a good idea to use LVM cache.
Okay.
Unless you have a very bursty. I mean, obviously it depends on the workload, but unless it's a very bursty write or large writes. Yeah. So LVM cache is really for, it looks like it's for very specific setups and workloads.
Yeah. Presumably, if you had something like an Optane, you could probably make really good use of that for something like this, I bet.
Yeah.
Because then you have
exactly.
high write endurance, and it has lots and lots of headroom. So, yeah. Well, cool. This is really interesting. Good job.
Yeah, exactly. For the full throttle one, the wall is really the best setup, because it's not a good idea if you full throttle workload with the NVM cache. It's not a good idea flushing. Yeah, so that's really the conclusions that I've gotten to. That's it.
All right. Well, thank you. That was neat. Any questions, guys, or any thoughts on that? All right. Well then, I think next week I am flying out to Cephalocon early, so I think we're going to cancel for the next 2 weeks to account for all the folks that are going to be gone. And then I believe we should be back after that on the 30th. So just remember, we'll this meeting will be canceled for 2 weeks, and then we'll see you guys then. So hopefully see you at Cephalcon, but if not, then see you on the 30th. See you later, guys.
Thanks, Mark. Bye bye.
See ya.